Hello everyone, this is the third lecture of the series of SolidWorks tutorials. In this lecture we discuss about the 2D module elements. Previously we discussed about line, circle, rectangle. In today's lecture we discuss about the polygon, arcs, slots, ellipse, splines and etc. So start with the new project here. So click on new, click the part icon of this window and then click OK. Now you can see your 2D module window is open. Now make sure that your sketch toolbar is available with you. Select the plane which you want to draw anything. So I select the front plane. On sketch toolbar, go to the sketch. Now you can see the plane is just 90 degree to the user. Now you can draw anything. So in previous lecture we discussed about line, we discussed about circles and we discussed about rectangle. In today's lecture we discuss about arc, slots, polygons, splines and ellipse. So starting with the arc. Now arc is basically consists of three types: center point arc, tangent arc and 3-point arc. So we start with this 3-point arc first. So I select this 3-point arc here. Now I started from origin. Let us give the first point of the arc here first, and then second point anywhere. You can give in the upward direction, you can give in the downward direction. See, the orientation of the arc changes. When I give the arc second point in upward direction, the orientation is towards the clockwise direction, and if I give in the downward direction, the orientation is in anti-clockwise direction. So I just click here. This is the second point. Now you can give the third point of the arc, so that arc can be created and extended to a certain extent. So you can extend up to that amount which you want. Fine. So let us say I just extend the arc in the upward direction here. So I just delete. So this is how your 3-point arc can be created. Press escape to end the command. Okay. Now you can see first point of the arc is this origin, second point somewhere here, and third point I click anywhere on the screen in upward or downward direction. Your arc is created in that direction accordingly. Okay. Now the second type of arc is your tangent arc. Tangent arc is the arc which always require one element before starting it. Okay, because tangent arc means that every arc you created continuously is tangent to the previous arc. I can show you here. Now click on tangent arc first here. Now you can see this is the arc which is previously made. So I can start this tangent arc from this point also, this point also. Let us start from this point. Just I click here. You can see the arc is continuous. Continuous means it doesn't appear to be disappear after implementing the command. Okay, so just like when you draw a line, when you draw a basic standard line, it will continuous until you cancel the command. Similarly, this tangent arc remains continuous until you cancel the command. Okay, so this is how you can create the arc. This is your, we can say, tangent arc here. Press escape to end the command. See what happens now. This is the first arc I created with the help of 3-point arc. This arc which starts from this point and ends at this point is a continuous arc, and it is named as tangent arc. Why? Because when you draw this arc first element, this is the first element of this tangent arc. This is tangent to this previous arc which I draw earlier with the help of 3-point arc command. Okay, so this green symbol shows here a circle with a line. This is basically constraint of tangency. Okay, so similarly the second element of tangent arc is tangents to the first element of this arc, and similarly this is the third element of this arc which is tangent to the second element, and so on. So tangent arc means your next element of arc is always tangent to the previous element of the arc. So there are at least 1, 2, 3, 4, 5, 6, 7, 8 elements in tangent arc which is continuous in nature, and they all are tangent to each other. continuously. Okay, and tangent arc requires element before starting it. So it may be arc, it may be circle, it may be a line, it may be a rectangle, anything else. It may be some other element, but it requires an element to start with. Okay, that's why now let us say if I just draw tangent arc here, see, it requires an endpoint to sketch segment. So it requires one element before starting it. So that's why I just create one arc first with the help of 3-point arc, and then with the help of 3-point arc I try to construct a tangent arc which is tangent and continuous in nature with the previous arcs. Okay, so this is how you can create the tangent arc. And the last type of arc is your center point arc. Center point arc means you give the center first, then the other 2 points to create the arc. Okay, so I just drag it somewhere here. I started from here. This is the center of the arc. Now give the radius point. This is the second point of the arc. Center of the arc is this, and second point of the arc is somewhere here. Now you can drag in anti-clockwise direction, or you can drag your mouse in clockwise direction. Depending upon that, your arc is created. Okay, whether you require the whole arc, you require this is, you can see here the arc is created in clockwise direction. Then if you want to create in anti-clockwise direction, you can give accordingly. Suppose I just drop here my third point. So this is the first point is the center, second point is the radius point, and third point is somewhere else where you want to stop that arc. Okay, similarly I can draw another arc with the help of this. Let us say this is the center of the arc, this is the center of the arc, this is the radius point of the arc. I can draw it from anywhere in this direction. So let us say I draw it from this side. This is how you can create this arc. So arc can be of three types. First one is your center point arc, then second is tangent arc, and third one is your 3-point arc. So mainly we use 3-point arc mostly. 90% of the cases we use 3-point arc, but when drawings are a bit complex, then we always use other type of arcs as per the design requirements. Okay, so now let us delete these all elements. Select with the help of green selection window, press delete on the keyboard. Now next type of element is your slot. Slot is basically used to create a donut like structure which is elongated in horizontal direction. Okay, so first type of slot is basically a straight slot, then second is center point straight slot, then 3-point arc slot, then center point arc slot. So basically we use this straight slot most of the time, but if the drawings are a bit complex and where the chances that this slot is not available or this slot is not as per the requirements, then we use it in different types of slots here. So first we start with straight slot. So straight slot means we require 2 points here. First point, let us say I start with the region. First point, this is the region. Second point we somewhere give here. Now drag your mouse upward and downward without clicking the mouse. Okay, just dragging your mouse here. I just maneuver my mouse on the screen. So if I'm moving in upward direction, see, this is how your slot starts building up. So I just click somewhere, anywhere. So this is your slot here. Press escape to end the command. If you want to give the dimension to the slot, just go to smart dimension. So first dimension is given to this arc here. So click here, and this is you can see here, this is R. I previously told you that radius is meant for arcs as well as some fillet elements, and if you want to define the circle, you must define in diameters. Let us say this radius of this arc is 160. Now you want to give second dimension is given to this straight line. This is the construction line of this slot. So I just click here and give, let us say it should be 370. Then you can see here the structure is now black in color and it is fully defined. Fine. Now you can see your straight slot is created by just giving this radius here. You can give the radius this side also, no issues, and giving the straight dimension or horizontal dimension to the construction line of the slot. Second type of slot we have center point straight slot. So just click here. Let me make sure some screen. Now first point is given. See, the line expands from the center point. See, this is how a line expands. It is just similar to the midpoint line. Your midpoint line is expanded from the center point like this. Now wherever at what inclination you want, you can give anywhere on this direction here, like clockwise, anti-clockwise, any inclination. Just let us say I just click here. So this is your, you can drag your mouse somewhere else, anywhere else on the screen. So just click here. Okay, so this is the midpoint. From this midpoint your construction line expands in both the direction with the equidistance, and then you drag, just click here to end that command. Okay, or you can say you can define the length of slot with this click or with this second point. Okay, and then third point is your drag point, by which you can define the dimensions of the slot. Press escape to end the command. You can give dimensions previously, like you can give the dimension to this arc. If it is okay, then press enter, and you can give dimension to this. See, this is now horizontal dimension. If you want to give your align dimension, you just drag your mouse accordingly. So this is your align dimension. Fine, you can give dimension to the slot like this. Then next type of slot we have is 3-point arc slot. So it is similar to the 3-point arc, but in case of slot you just drag your mouse to give the slot structure to the arc. Okay, so what I do, I just give first point of the arc, then I give second point of the arc, and then I give third point of the arc somewhere here, and then you can drag your mouse. You can see your slot is created in this format. So this is the construction line of this slot. This arc is the construction line, and this arc is defined or characterized by 3-point arc. You give the first point, second point, third point, and just drag your mouse to give the structure of slot to this 3-point arc. Okay, you can also give dimensions, just pressing the smart dimension here, give the dimension to this, press enter if it is okay, and then you can give dimension to this arc also, and then enter. Okay, and you can define the distance of this center point or this origin, this starting point of arc, so that it should be fully defined. That is a part of another lecture we will discuss later on, but for the meantime, you know how to you must learn how to draw these slots. Okay, so last type of slot we have center point arc slot. So it is also similar to the center point arc, but just giving the shape of slot, that's why it becomes center point arc slot. Okay, now as we can see, let us say this is the first point, this is the center of this arc, and this is the second point, that is called radius point of the arc. And now you can drag your mouse in anti-clockwise or clockwise direction, or clockwise or anti-clockwise direction, so to create this slot. When I just end this point here, okay, and then drag my mouse, see what happens, the slot is created. You can also give the dimension, press escape to enter the cancel the command. Okay, now again I just do it again for you. Center point arc slot, first give the center, then give the second point or the radius point of the arc, and then give the direction or sector at up to which you want to draw your slot, and then drag your mouse to give the slot structure to this arc. Press escape to cancel the command. So this is how you can create the slots. Okay, and they are very useful when you want to create some holes in the 3D elements. That's why we use slots, because sometimes you have to create two circles, then join with the help of straight line, then trim those lines. It's very cumbersome. So beside this, you draw a slot as per your requirement, give the dimensions, you get your structure. Okay, so this is the slot. We learn about arcs, slots, and then we have polygon. Let me delete all these elements first. Control 8, so that our origin comes in 0, 0 position. Now let us say we have to draw polygon. When I click on this polygon, now you can see in property manager the polygon asks me about the number of sides from this parameters. See, this is the parameter option here. So if you want to give the number of sides, let us say by default it is 6, then hexagon is created, 7 septagon, 8 octagon, 9 nanogon, and 10 decagon, and so on. The amount of sides you want, you can fill it here. Let us say I just create 8, press enter, and then second option, it asks you that whether the polygon is inscribed in the circle or whether the polygon is circumscribed by the circle. So inscribed circle means that your polygon is created with this construction circle which is inscribed in the polygon. So let us give the center of this polygon here, and you can see a polygon is created. It has 8 sides. See, the circle which is constructed, this polygon is inscribed in the polygon. See, it is inside the polygon, that's why it is inscribed in the circle. Okay, now again if I click circumscribe, what happens? The circle which creates the polygon is outside this circle. So this is the basic difference between inscribed and circumscribed. So inscribed circle means the polygon which is created by the construction circle is inside the polygon, and circumscribed means the polygon which is created by the construction circle is outside the polygon. And to end the command, press escape, your command is ended. Now you can see this construction circle is basically used to construct this polygon only. It has no characteristics, it doesn't have any issues when you make the drawing, transfer the drawing from 2D to 3D element. Only 3D of polygon will occur, and the construction circle will remain same. You can hide this construction circle by just right click. You can see an option here. See, for construction, or you can make sure you can't delete this circle. Okay, if you delete this circle, your polygon will become unstable and very difficult to make sure that it will become fully defined further later on. Okay, so make sure this circle remains with the polygon. Fine. So if you want to make sure that this polygon should be inscribed in circle. Okay, so now how to give dimension to the circle? Go to smart dimension. Now if you want to dimension this circle, so just click here. Now this is the circle of 350 diameter used to construct the octagon, that is a polygon which is circumscribed by this circle. Okay, also you can give the dimension to this edge also. Let us say it should be 120. See, now it is fully defined. Here you can see it is fully defined. Fine. So what happens? You define the construction circle, you define one edge, your whole polygon will become black and it is fully defined. So this type of drawings we need. We always make sure that all the drawings are black in color. We have to make sure that your system, your drawings, your elements are black in color. That will make sure that they are fully defined. After this we go to the 3D. We transfer this 2D drawing into 3D. Okay, if any line, any point is blue in color, make sure it is movable. You can move it, you can edit it. So when we make transfer 2D to 3D, it may get chance that that element will not get converted into 3D. It may distort your drawing and it will produce some error while converting 2D to 3D drawings. Okay, so make sure that your drawing should be fully defined. And fully defined, for fully defined structure, we prepare a lecture on it, and I will show you how to make your drawings fully constrained with the help of 3 constraints methods. Okay, so that will be a later part. We discuss it later. Now you can make sure that you can see here that your polygon is created with the help of this construction circle of 350 millimeter dia with a side of 120 millimeter with the number of sides as 8. Okay, now if you want to make more number of sides, then you can make sure that you just click here, you give the value as 12. Okay, let us say it is inscribed. Now I use inscribed in circle. Okay, now give the center, click somewhere else, escape it. Now you can see this polygon is created with this circle which is inscribed in this polygon, okay, having a 12 sides, and it can be given some dimension, let us say smart dimensions. Click on this circle, give it as 250, okay, and you can give some dimension to this also, let us say it is 70, fine. And this is how you can create this polygon. So we discuss about arcs, we discuss about slots, and we discuss about polygons. Now come to the ellipse. Now let me first delete all these elements here. Now ellipse consists of ellipse, partial ellipse, parabola, and conics. Okay. Now ellipse is basically consists of two different axes to create it. First one is major axis and second one is minor axis, or you can say major diameter, minor diameter, or sometimes we call it as major radius or minor dia. So there must be two parameters to create this ellipse. One is major, another one is minor. It can be diameter, it can be radius. Okay, so first we start with ellipse here. So for ellipse, let us start with this origin from 0 0. I'll give the major diameter first, so, or you can say major radius. Let us say this is my major radius, and now it asks me about the minor radius. Let us say the minor radius is this, and now I just click OK here. Your ellipse is created. Now you can see this ellipse is created. Now you can give the dimension like this, from this point to this point. You can give dimensions like 630, and you can give dimension from this origin to this vertical line here. So let us say it should be 180. Fine. Press escape to enter the command, and you can drag it by pressing Ctrl and mouse roller downwards. Put your mouse roller downwards and press Ctrl so that you can drag your drawings, okay, on the screen. Now what happened, my drawing rotates bit, so I just press Ctrl 8 and your drawing appears to be on your screen as per the requirement. Okay, so this is how you can create the ellipse by providing the major radius. This is the 630 is your major radius, 180 is your minor radius. You're providing two parameters to construct this ellipse. Okay, now second option is partial ellipse. Partial ellipse, click on the partial ellipse. Now you can give the first same conditions, give the center point of the ellipse, then give the major radius, then give minor radius. Now you can use, or you can choose at what point you want to stop the ellipse to make sure that like this. If you want ellipse up to this point, 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 in any direction, clockwise or anti-clockwise. So I'm just making right now in clockwise. I want that ellipse should be up to this point. So this is known as partial ellipse. It is ellipse. It consists of two parameters, major radius, minor radius, but it is not formed fully. It is not closed with ends. It has certain gap between this. So this is basically known as partial ellipse. Sometimes we require such type of structure in surfacing, like when we draw any complex structure where we require such kind of elliptical structure. So we use partial ellipse. Then next we have parabola. So for parabola we required one focus point. Okay, so we start with this. This is the focus point here, and then we give the vertex point here, somewhere here. And now you can drag your parabola from this point, see, or you can from this point. So parabola can be created. So required focus point, vertex point, and then drag anywhere or click anywhere to start your parabola from that point. Okay, again we do it. We click on parabola, we give the focus point, we give the second point, and then we give your starting point from where the parabola you want to start, and then you can do this. See, so this is how you can create your parabola. Then next, lastly, we have conic sections. Conic section is hardly used in this software. very rare, but in surfacing it is, these sections are very useful when you need curves, like when drawing bumpers of your cars or bonnets of your automobile structure. You required some conic sections, parabolas, spherical sections, so that in that case you need such structures. Okay, so for conic section you give the first point here, second point here, and now you drag your section to anywhere. See, so this is the flexibility. You can provide this structure for creating fins also for aeroplane structures. So this is how you can provide the conic section. So this is the first point, this is the second point, and this is the third point here. From this point of edge you provide the distance up to which it can be extended. So this is the point I end the conic section. So this is how you can create the conic section in the drawing. So first select all these elements to delete. So this is your ellipse here. Now in case of spline, spline is just we use only first part of spline. Style spline and equation driven, these are basically Bezier curves. So they are used when you need some calculations or you need to make a profile with the Bezier curve structure. So you need some calculations to draw it. Okay, when you use, then you use equation driven curves, and for that you need some equations. So these can be useful when you have some complex piping structures. Okay, then we use splines here, equation driven splines or style splines. Most of the cases we always use simple spline here. So just click spline here, started from the region and click. See, it is a continuous structure. It will not stop until you give command to cancel it. Okay, press escape to enter the command. So this is how you can create a spline. It's a continuous structure. You can drag it from here so that you can make changes to this structure. So there are the endpoints where you can use them, and you can also use these arrows to change the structure of this spline also. Okay, so this is how you can create the spline on the software. So just select all, delete. So in today's lecture we discuss about the arc, slots, polygon, ellipse and spline. Lastly we discuss about your fillets and chamfers. Okay, so this is the last part of this sketching elements. Let us draw a center rectangle here. Press escape to enter the command. Now go to the fillet part here. So first one is your fillet. Fillet is a radius structure. Chamfer is a straight structure used for just chamfering or filleting the corners for aesthetic appearance. Okay, so sketch fillet. Now when you click on fillet, you provide the, here you can see in property manager, entities to fillet. So you select the entities you want to fillet, and then in fillet parameters give the value of amount of radius up to what radius you want to produce the fillet. Let us say I produce 10 mm, so I just click this point here. Okay, you can see a fillet is created. I can zoom it. See, a fillet is created of 10 mm. Now you can change the parameter to, let us say it should be 100. Press enter. Now you can see that this fillet is also created. It is also very small right now. So let us say it should be 500. Now it is visible to you. Okay, this is a yellow color structure here. So if I make it 1000, maybe more than that. See, so this is how you can create fillet. Just click on this vertex, and from that vertex it creates the fillet. When I just click OK here, so this is how you can see your fillet is created. Okay, press OK. Now fillet is created. It automatically gives the dimension R5000. Okay, this is the radius of the fillet. So now if you want to create a chamfer, go to fillets, select chamfer. Now chamfer is of two types. First one is angle distance, second one is distance. So see, you can see here in the property manager in the left here. So first option is angle distance. So you give the angle and distance here. So okay, so 45 degrees is the angle at which the chamfer takes place, and the distance is the distance from its starts to its vertex, from the vertex to its extent. Okay, so let us say this should be around, again I choose 500, enter. I choose the this vertex here. Okay, you can choose lines also, you can choose vertex. So vertex, when I choose vertex, see this is very small, you can't see here. The chamfer is created. See, this is the angle, this is the distance from this corner to this point, also this corner to this point. So it remains same, 5000 here horizontally, 5000 here vertically, and this corner and this line is 45 degree to this vertical line. Okay, so if I make it 5000, okay, take I have to choose another corner here. So just go to chamfer, select chamfer, select this 5000. See, at 45 degree, this is the angle, this is the distance. Press OK. So this is how you can create a chamfer. Chamfer is a straight line. Fillet is a radius, just a radius joining the two elements or joining the two sides of the rectangle. And the last again type we have select chamfer. Now the next is distance. So this is how you can give distances. So first one is 5000, another one is I should write 1000. Okay, here I just choose the corner, so you can see 10,000 from this side vertical, 5,000 from horizontal. So by default it uses this structure, this type of construction. It gives 10,000 to the vertical and 5,000 to the we can say horizontally. If you want to change, just click 10,000 here and 5,000 here, enter. Okay, so this is how you can create the chamfer with distance option, with angle option. Okay, this is angle distance option, and you can create here a fillet of radius 5000 joining these two sides of this rectangle. So this is your basically your all the basic element structures, and you can see how to draw them on 2D module of this software, like line, circle, rectangle, arc, slots, polygon, fillet, chamfers, ellipse and splines. So these are basically used elements to create some a proper drawing. You can use lines to create straight lines, arcs to create fillets and so on. So with the help of these basic structure elements you can draw anything, and then make sure these elements are fully defined, and then lastly they are converted into 3D element, from transferring from 2D to 3D element. So this is basically your we can say that basic structuring of elements, basic drawing of these all basic elements. And in next lecture we discuss about how to constrain things. That is the major part of this tutorial series, that if you constrain the things properly you will get all the things further in a systematic way. Okay, if you constrain things wrong, then definitely there are chances that your structure is not converted to 3D properly. There are some distortions which is very difficult to remove later on. Okay, so in the next video lecture tutorial we discuss about how to constrain things, how to make use of constraining maximum instead of giving dimensions every time. Okay, we can use constraints a lot as compared to giving dimension to each and every element again and again. Okay, use constraints then. Now constraints can be of three types. First one is geometrical, second one is dimensional, and third one is constraint through region. So constraining can be of three types, and we discuss all the constraints in the next lecture, how to constrain the things, how to make sure that things are properly constrained and fully defined. And the colors, now you can see all the lines are right now blue in color, and you can drag these lines here also. See, this happens when you not constrain your drawings, when you not fully define them. This happens. Okay, and make sure this doesn't happen, so that you can convert these color of the lines blue to black. When they are converted completely black, then here in the bottom you can see it is written now under defined, but when they are black it is written by fully defined. That means your structure is fully constrained with all the constraining parameters. Okay, so in the next lecture we discuss about constraints, and further we will study all the different parameters of constraining. Okay, so for today I think it's enough. You can go and practice all these commands and know how to draw them, and thanks for your support, and thanks for the watching.